to talk about relations and functions briefly. So what is a relation? You might guess the word relation kind of describes what it is. A relation is a relationship between two variables or two numbers. Sometimes it's officially described as a set of ordered pairs. Here's a set of ordered pairs. When x is 2, y is 3. That's a relationship between 2 and 3. When x is 5, y is 7. When x is -1, y is 6. I'm showing a set of ordered pairs. This is a relationship between two numbers, or two variables, if you will. This is another way I could write a relation. This is kind of a different format. I'm saying this is my x, this is my y. So when I have my x is 2, out comes a 5. I could also write that as an ordered pair, 2, 5. When I put in a 3, out comes a 5. When I put in a 4, out comes a 6. This is also a relation. It's showing a relationship between two things or two variables. Hey, look, I could show a relation as a graph. Here are my x values, here are my y values. Now, this is a set of an infinite number of points or an infinite number of ordered pairs. Every time I plug in an x, I get out its little y. I can plug in another x and get out another y. So there are all the points that make up my relation. That's what a relation is. So now, what is a function? Okay, we are about to find out. So a function is a relation, but it's a special kind of relation. A function is a relation where each x value, each input, goes to exactly one output. Think of a function as a machine. If I put in a 2, I get out a 4. If I put in a 3, I get out a 6. A function is like a machine. It's something that works. When you put in something, you get out one thing. Okay, so this means when I put in a 2, I get out a 4. So that's the ordered pair 2, 4. When I put in a 3, I get out a 6. That's a function. So what, you may ask, is an example of something that's not a function? Well, that's right over here. This is not a function. When I put in a 2, well, this machine is not working very well because sometimes I get out a 4 and sometimes I get out a 6. This is not a function because when I put in an x, I get out more than one thing. So a function, again, is when you put in one input, you get out one output. So each input, each x, corresponds to exactly one y. Each x here does not correspond to exactly one y, so that is not a function. You getting the hang of it? So, a function is a relation. A function is a relation. In other words, it's a relationship between two variables where each input, and usually we talk about that as our x values, corresponds to exactly one output or y value. If you need to pause this and write that down in your notes. A function is a relation. It's a relationship between two things where each input corresponds to exactly one output. When I put something into a function machine, I get out one thing. Okay, let's look at some more examples of functions. So we've been looking at ordered pairs of relations. So let's take a look at ordered pairs of relations that might be a function or might not be a function. What do you think? Is that a function? Does each input, each x, just go to one y? Well, we can write it like this if that helps. Here are my x values. Here are my outputs or my y values. Where does the 3 go? It just goes to 5. Perfect. So far, so good. Where does the 4 go? It just goes to 6. Perfect. Where does the 7 go? It just goes to 6. Okay, yes, this is a function. This is a function because when I put 3 into my function machine, I just get out one thing. When I put 4 into my machine, I get out a 6, and just a 6. When I put a 7 in, I get out a 6. Now, some of you might be saying, but wait, you get the same result with 4 and 7. That's okay. That's still a function. The only thing that you need to be clear on is when you put in an input, you just get out one answer. Okay? If I ask you, what's 3 plus 2? You just say it's 5. It's not 5 and sometimes 6, right? There's one output. There's one result. Let's look at some other examples of functions. Now, functions are things we've actually been dealing with functions. When we've been working with linear equations, that whole time it's been a function. Let's look at y equals, 2x plus 1. There's a y-intercept of 1. My slope is up 2 over 1, up 2 over 1. This is a function. And we often call it a linear function. And I think you can see why it's a function. Each input has exactly one output. For example, when I plug in a 0 for x, I get a 1 as my output for my y. When I plug in a 1 for my x, I get out a 1, 2, 3, a 3 for my y. And there's an infinite number of points. I could do this until the cows come home. So this is an example of a linear function. Each x just has one y. Each x has one y. Whatever you choose to plug in for x, you're just going to get one thing out for your y. That makes this a function. We've done some other functions too. We've done quadratic equations. Hey, those are functions too, and you didn't even know it. Let's just say this is, I'm just making this up. X squared minus 5, let's say. That's a quadratic function. Now, it kind of takes some time to train our eye to look at a graph and to see if it's a function or not. But I think you can see that if I plug in an x value, here's your x, here's your y. Okay, boom! I'm just going to get out one y value, right? When I plug in this x, boom! It just has one y friend. When I plug in that x, boom! So whatever input I put in, I'm just going to get one output. And again, if I wanted to, I could actually do it with numbers. Let's put in a 0 for x. When I put in a 0 for x, I get 0 squared minus 5, negative 5. Okay, there's 1 point on this quadratic function. I could put in a 1 for x. 1 squared is 1, minus 5 is negative 4. Okay, there's another point on this quadratic function. No matter what I plug in for x, I'm just going to get out one answer for y. That's what makes this a function. Hey, should we look at some things that are not functions? Okay. These are some counter examples. These are not functions. There's still relations. Still going to be a relationship between two numbers, but these are not functions. Okay. We already looked at one of those. Let's look at a set of ordered pairs. I put in a 2, I get out a 7. I put in a 2, I get out a 14. I put in a 3, I get out a 1. I put in a 5, I get out a 0. Oh no, danger, Will Robinson. What's wrong here? Yeah, look. That 2 is fickle. Sometimes the 2 produces a 7. Sometimes the 2 produces a 14. That is not working for a function. Now, this is a relation, but it's not the special kind of relation that we call a function. Does that make sense? What would a graph look like of something that's not a function? Well, let's see. When I plug in an x, I want to get out more than one thing. So maybe a graph would look something like this. That's not a function. If I were to put in, let's say, where x is 1, look. It has one y value up here, and it has another y value way down here. That's not a function because when I put in an x or an input, I get out more than one output. Let's see, what else would not be a function? I guess anything that kind of crosses over itself. Woo! That's a fun-looking thing. That would not be a function. Look, if I were going to plug in, let's say that's x equals 1, it has a y value right there. It's got another y value right there. It's got another y value down there. That 1 would be really fickle. It has 3 outputs. That means that's not a function. Okay? So, a function is like a machine. When you plug in an x, you get out exactly one y. When you plug in an input, you get exactly one output. Now, of course, there is a shortcut for graphs. Okay? I don't really like shortcuts, but it might help you. It's called the vertical line test. And it can help us because sometimes it's a little hard to train our eyes when you're looking at a graph. Let's say I have a nice quadratic function. Now, I've already told you it's a function, but what if I gave this to you and asked you, is this a function? One way to kind of test it is to think about drawing vertical lines. If my vertical lines just go through this graph once, for each vertical line, that means that each x value just has one y value, and that means it is a function. This just passed the vertical line test. In other words, wherever I drew a vertical line, it just touched the graph one place per line. That means this is a function. Let's compare that to something like this. If I draw my vertical lines, oh, look, I already bumped into the graph 3 times. Look, I'm drawing vertical lines and it's intersecting the graph in more than one place. So that failed the vertical line test, which means this is not a function. This is not a function. So that's a nice little shortcut to determine when a graph of something is a function or not. All right? Okie doke, I hope this helps.